Florida Railroads Administration Office of Railroad Safety Motor Power and Equipment Compliance Manual, July 2012. Chapter 16, 2012. Chapter 16, Wayside Detector Train Inspection Guidance, Association of American Railroads Class 1 Railroad Initiative. To reduce, mitigate, and adversely affect the heavy axle loads of the axles on the track infrastructure, degradation of the freight components and the tools enhanced with the train inspection. The railroad has served leveraging emerging wayside detection technology based arrest high and distress and unsafe stress state equipment of the track. The railroad intended to achieve at a minimum an equivalent enhanced level of the railroad safety by using wayside detection technology. To achieve the goal, this advanced technology safety initiative was implemented on October 1st, 2004 by the Association of American Railroad Technical Service Working Committee. The Advanced Technology Safety Initiative is predictive proactive maintenance system that uses the best available technology to detect and report potential safety problems in poorly performing equipment before the result of accidents or undue rail damage. The overall objective of the railroads are to enhance the quality and efficiency safety of the train inspection process through technology, including the assessment of the underlying causal issues. It is believed to be that the mature wayside detector system can be provided with the remote intervention capabilities by combining the facets of the technology that relate with the preventive incidences and detection of incidences and notification of incidences with recovery of from incidences. Under the auspices of the Association of American Railroad, Class 1 Railroad, and private cars owners have already embarked upon the technology driven with the train inspections. There are a variety of wayside detectors, over 130 already deployed throughout the U.S., and deployment is rapidly growing. The initial objective of the undertaking was reduced to a stress state of the railroad, that is to fix the remove and revenue service problematic equipment, poorly performing defective equipment, but before it has severely damaged the track infrastructure. Thus, the predictive proactive maintenance system for the in-service equipment identifying with the component deteriorating, performing through the different levels of degradation to the final level, at which time operations must be interpreted to mitigate the condition. The concepts consist of successive triggers to indicate the progressive degradation and preventive actions to be taken. The wayside detector technology consists of three general categories: wayside performance detection, mechanical machine vision, wayside condition detection. Under the automated or ATSI, which is Advanced Technology Safety Initiative. The initiative of all the technologies eventually feedback to the Transportation Technology Incorporated, or TTCI, Integrated Railway Remote Information Service as a system, which will then feed the stored data to the Equipment Health Monitoring System of the Rail Incorporated, which is the Association of American Railroads IT headquarters at Cary, North Carolina, that generates the equipment alerts the car owners of the equipped health monitoring system through the equipment monitoring system. Table 1 shows the detector location of the railroad city. We have BNS Freight somewhere around Colorado, Arizona, Conrail, and everything, like CSX. The intern IRS data warehouse successfully through the internet is designed to assemble and integrate with the data all the type of devices, the monitoring vehicle performance, and return add value to its users in quantitative evaluations of the rail vehicle performance by enabled planned maintenance and monitoring post-maintenance performance to provide quality control checks on the maintenance performed. Rail Incorporated, located in Cary, North Carolina, is the industry's largest but most accurate source of real-time interline rail data. Rail Incorporated means the industrial reference of the Ulmer data electronic response that contains critical data for the North American transportation equipment, depicting a list of all nationwide fleet by cars and number of the specific car data, the railroad's equipment of the owners, agents, shippers, port suppliers, industrial compliance, government agencies, car maintenance facilities, and all users under Ulmer. The first effort under the new initiative is that the new data of the wheel impact load detectors or wild to monitoring the health and service real car wheels. When the freight car wheel exerts a peak impact load of 90 kipss above and measured by the wheel impact load detector's site is not operatively effective, considered out of round on the path to failure. The program provides a window for the opportunity that opens the wheel reaches of the peak impact load of 65 kipss. This is the very first wheel impact load detectors started appearing at Conrail in the early 1990s to protect against flat wheel impacts on the concrete ties. It appears that the wheel impact load detectors technology has been quite useful for the indicating progressive component degradation, successful wheel impact loads, thresh as alerts through as levels. See wild description later. Future consideration of wayside detectors. FRA encourages the use of the new technology and appropriate with the Federal Railroad Administration's mission to promote railroad safety. To carry out the mission of the FRA that enforces federal safety standards. The safety standards are tailored to technology that exists at the time and they are promulgated. Often the new technology can be used in conjunction with existing technology to enhance safety. Railroad also increases the use of the wayside detection technology. Their embedded event recorders to assess the cause of train accidents, derailments. This information can help the FRA determine accidents, derailment investigation following the list of common ways to the defect detector features. Data-driven tools. These are bulletins. I'm just going to read them. Data-driven tools for railway vehicle owners, vehicle builders, vehicle maintenance and component manufacturers. Products and monitoring performance from the wayside. Capabilities for use in the new predictive and condition-based rather than reactive vehicle maintenance decisions. Automation of the communication process. Car owner access to the equipment to intervene and effective predictive maintenance strategy. Improve maintenance planning and schedule for proactive management component with lifecycle optimized schedule vehicle repair, automated maintenance inspection for implied reliability measurements, and reduced need for the manual inspection finding defective car and truck components. Improve safety, improve utilization car fleet, reduce damage to the track lighting, the capability of crossing the reference data to produce more efficient gains, supplements carry current inspections, add a new network efficiency, network management, and detector data from all the railroads, continuous update inspection records of each of the car from the critical running gear and performance, interchange the data with the other railroads car owners in advance of car interchange, enhancement of line point automated incoming lineup of the workload, definition predictive workload, providing easily view print workload for the incoming trains and cars, speeding up the normal visual inspection, targeting only the problem cars, extending intervals between conventional visual inspection. Enhancement of the railroad and car owner, the mechanical task over the car, and the health and warnings by using continuous automated electronic from the spell of the symptoms, preventing action, directing maintenance for the less of the disrupted time in the car compliance, using training and analysis to optimize maintenance cycle, instructing special attention handling the probable cause, verification, accountability, ability to audit. Continuing. Waivers issued. Notability, the Union Pacific Railroad, or UP, recently applied for the granted relief of the single-car air brake test, or SCBATs. An empty car utilizing defective information irregularity wheels and defective bearings gathered from wayside detectors such as wheel impact load deficiency, ABD, HPD, AWD, WPM, WPD, and TAD. These reliefs involved the empty cars of the Union Pacific North Plate Northeast facility wherein the replacement of the non-federal railroad condemning wheel set minor defects of the condemnable and the Air Association of American Standards in ongoing per Union Pacific in-train wheel set replacement program as a preventive maintenance tool. A copy of the Safety Board approval letter dated on January 16, 2009, granting the waiver compliance with Title 49 CFR 232-3L5B2 is located in Appendix B. For further details of the waiver, the FRA docket, the FRA 207-28-454. Alright, wayside detector glossary terms the best in understanding nomenclature language. Wayside detectors can currently be used for the U.S. glossary of these terms that have been provided. ABD, acoustic bearing detector, measuring acoustic signatures and indicating bearing defects and significant derailment prevention. AIC, automated inspection components. AOA, an angle of attack of the wheel is defined by the angle between the track radial line and the center line of the wheel set axle. It is measured by the lateral creepage, lateral loads exerted on the track indicates the dynamic behavior and the curving of the performance of the bogie. I value indicates the value of the defects and potential wheel climb derailment. ASAIS, Automated Safety Appliance Inspection System, measuring dimensions, detecting missing appliances, compares standard signified set of performance. BOG is a burn-off journal resulting with the roller bearing overheated and seizes. This condition can generally result in missing of the portion of the effective axle. The axle journal becomes associated bearing may be discolored and completely separated from the rest of the wheel set. The broken rail detection, acoustic method of fiber optics, the strain gauges of the track circuit signifies derailment prevention from the broken rail. BSM, brake shoe module, measuring thickness, measuring missing parts with the video machine vision, indicates that the brake shoe defect, signifies the damage prevention. CAD, cracked axle detector, usually a laser, generates the surface waves along the length of the axle, measures amplitude of the generated waves, and the air-coupled ultrasonic transducer detecting cracks as reflected waves by signature cracks, signifies derailment prevention. CWD, crack wheel detector, user laser air hybrid ultrasonic technique, or LA HUT, to create a surface body wave of the wheels where they are then recorded using the air coupled ultrasonic transducers and modification of waves. Reflection and refraction of the crack is detailed with a combination of peaks in the frequency domain, signifies derailment prevention. DED, dragging equipment detector, signifies damage or derailment prevention. HPD, hot box detector, measures temperature change, indicates the rolling bearing defect, signifies derailment prevention. HWD, hot or cold wheel detectors, measuring wheel temperature, indicates the air brake system defects and signifies brake performance. IAM, interacts misalignment, internal misalignment between two wheels set in the bogie, measured with the AOA axle of AOA is axle of an angle of attack of the leading wheel set minus the AOA, the angle of attack of the trailing wheel. The IAM interaxle misalignment dynamic performance, such as the higher value, indicates the vehicle defects. Lower air hose detector measures the air hose height above the rail using the video machine vision, indicates the coupler air hose defect, signifies the train to stop the performance. OLED, overload imbalance load detector, measures the wheel load imbalance using the wheel impact load weighing in motion, and identifies shift load, signifies the curving performance of the derailment prevention. Rail flaw detection, laser-based ultrasonic NDT, or non-destructive test, signifies the damage prevention of the rails with flaws. TAD, trackside acoustic detector, measures acoustic signatures and indicates the roller bearing to be defects and signifies derailment prevention. The T-bogey is a truck bogey optical geometry inspection, measures geometry faults with alignment with the track of the bogey wheel sets using the laser optical means, indicates the bogey performance deficiencies, indicates the set of performance. T, the traction effort of the lateral distance between the center lines of the axles bogey and defined with the traction position, leading wheel end set and minus the tracking position of the trailing wheel set. Higher value of the tracking error also represents the degrading dynamic performance of the wheel. THD, a truck hunting detector, measures the lateral instability in the terms of poor lateral dynamic performance, indicates truck suspension defects, and signifies derailment prevention. TP is a tracking design defined in the center line of the wheel compared with the track of the track center line. This interim parameter, which is defined with the track error of the bogie. TPD, truck performance detector, measures lateral vertical wheels loads, angle of attack, indicates the truck suspension defects on curving performance, signifies derailment prevention. TS is a thermal scan using thermal sensors to detect generated interfaces between the brake shoe and wheel to determine when the brake application is completely with a BSM to assess the brake shoe condition and signifies damage prevention. WBT, warming bearing trending, measures bearing temperature because the detectors identifies exclusively trends. Wheel impact load detector measures impact load, indicates the wheel tread of the defects and signifies the damage prevention. The WPM and the WPD, wheel profile module and wheel profile detector, measures the wheel profile dimensions using a laser video scanner, identifies wheel and rim tread shape defects and signifies set out of the performance. WTT is a wheel temperature trending. Moving out of the definitions into wayside detector treaties. There are three aspects of the wayside monitoring railway vehicle. 1. Presenting the condition of the required maintenance. 2. The detection and diagnosis of developing flaws. 3. Training for the future performance preventive and the proactive maintenance strategy in the context with the wayside detector of two types, reactive system and predictive systems. Reactive systems detect actual faults of the vehicles. Generally, information from the reactive system is not suited for the trending, but it is important to protect the equipment for further damage due to the fault. Some example of the reactive detector technology are the DED, the HPD, and the HW. The protective systems, on the other hand, are capable of measuring, recording, trending of the ride of the performance of the vehicle. Also, specific components for the collected information and possible analyzing the condition of the equipment to predict possible failures, faults, and they may occur near and distant future. They may make it easier to plan maintenance activity ahead of and also the equipment in a more efficient way. Some examples of the predictive detector technology: ABD, TBD, T-Bogey, THD, TAD, WILD, WPM, WPD, AISC, AIS, and BSM. Alright, wheel impact load detector. The wheel impact load detector electronic collection device that measures the vertical wheel impact with the front of the damage of the wheels, and shown in figure 1 on the railway wheel with the man mounted with the strain gauges consisting of system strain gauges placed on the web rail, and shown in figure 2 and 3. The measure of the rail deformation under the traffic is measured importance measure impact forces caused by the flat shelled spelled out of the ground, build out of tread or damaged wheel. The high impact force of the damaged wheel of the cargo infrastructure, preemptive reduction, high impact force of the truing faulty wheels, removing damaged wheels entails benefits and use of the reduction of derailments, rail fatigue, bearing damage and cold weather, rail factors, truck damage, concrete ties, wrecking, wood type, cutting and incremental wheel and tread life, fuel efficiency. Figure 1 shows the damaged wheel. Figure 2 shows the typical strain gauge installation on a rail web and or over a crib. Figure 3 is a typical layout of the wheel impact load measurement sites. You have a 19 crib space versus 15 crib space. 25 ties, 303 inches, data collection, spaced out by 216 inches from the front end of the last one. The various features of the wheel impact load detectors figure 4 may include the impact of the force, monitoring the train vehicle information, bidirectional traffic, automatic car counting, identification with a valid car library, significant diagnostic instrument layout, while optimizing flat wheel diameters. The Association of American Railway rules standard compliance. The corresponding measures may include car IDs, wheel IDs, nominal peak and dynamic wheel loads, axle loads, train speed, length, and tonnage, and by train and by week and month. Data collection collected by the wheel impact load detector network of the U.S., Canada, and Mexico resides Equipment Health Management System, EHMS, which approval. The ARI approval of the reference file maintained with the rail incorporated. The various thresholds may be per Association of American Railroad fields indicated. The progressive component graduation as follows. The wheel impact load of the reading of the 65 kIPS is less than 80 kIPS is a single wheel indicated by the appropriate maintenance, repair, and intention, determining the window opportunity, alternate leave level requiring maintenance, issuing first maintenance advisory to the equipment health management system. While the reading 80 kIPS is to less than 90 kIPS is for a single wheel, indicating the warranted maintenance, repair attention term to the opportunistic repair alert level requiring issuance of second maintenance advisory of the equipment health management safety system. Wheel impact reading of the 90 kIPS to less than 140 kIPS for a single wheel, indicating an urgent maintenance repair attention term as an Association of American Railroad condemnable art level requiring issuance of third maintenance advisory of the equipment health management system, and for a wheel impact load reading of 140 kSPI or greater than a single wheel indicated required maintenance term as a final alert level resulting in issuance for maintenance advisory from the equipment health management system. Alright, this is digital picture, doesn't look that great so I can't read it, but it's a typical wheel impact load deployment revenue track indicating an instrumented rail over the cribs. Truck performance detector. Truck performance detector monitors response to the car's suspension systems along with the curved track signal warn defective component conditions detected by the truck performance detector are truck power steering, how the worn wheels, poor wheel load equalization. Detection of these elements add to the security area against the derailment. The truck performance detector measurement wheel rail forces vertical and lateral. Viva strain general gauge sensor on the rails and selective reverse curbs. They also measure an angle of attack, and the angle of attack. The angle can be taken from the axle relative to the direction of the motion of each axle, so of the respective wheel in the combination of the measured vertical lateral forces provided with the information regarded with the steering capability of the truck through the curve. The truck performance detector identifies suspension systems that do not perform optimally in or after negotiation of curves. Poor performance may result in derailments due to the wheel climb. Gauge spreading of the rail overlaying the truck panel shift, and poor performance also contributing to wear rail. Special track work wheel profiles flanges by identifying poor performance through the performance-based monitoring. Preventive maintenance can be performed in reducing derailment risk. Improving all overall safety in railway operations. Shows the vertical load and lateral load over here on this side, the flange high, low level, and low and load and level, vertical load, angle of analysis, warp track, high angle and angle of attack, truck panel shaft, the height of the next axle load, roll over the high truck side load and vertical load. Typical truck performance detector. A typical truck performance detector deployment of revenue S-curve the truck showing the vertical lateral load collected data and indicated the outcome of their high magnitudes. A typical truck performance detector sites may consist of an S-curve arrangement with the two curves typically at 4 to 6 degrees or the opposite direction related to each other, the right hand and left hand curve with the tangent section separating as shown in figure 6. This gives the possible to collect the data of the vehicles before both the right and left curves are as well as tangent track. Figure 6 shows a schematic showing an S-curve track location of instrumented cribs right there and right there and right there. 4 to 6 degree curve, 4 to 6 degree curve, central bungalow, 400 foot tangent spiral. I don't know what TAD means. TAD wayside detector monitoring bearings that automatically detected flaws in the wheels bearings, evaluating the acoustic signature of the noise. The I 1 gigahertz for the above of the created with the flaw of the figure 78 before the bearing becomes hot and seizes the surface as a result of the accident due to the burned off over the roller bearings. The most problem in the rolling bearings is due to the flaws of the cup spalls, cone spalls, spelled. Etched, air-seamed rollers, water-etched, raceways, spun or loose cones are rested with a certain plate with the rotation defective side bearings holding hollow tread wheels, although adding to the roller bearing woes. TAD can be the symptoms of bearing failure as much as earlier stage of the hot box detectors and can spot flaws of the visual inspection may not be detected, but the TAD detectors may be defined with the inner roller bearing defects long bearing before hot boxes build detect the problem, so avoid the possible derailment, the inevitable consequence of the cost safety disruption network. TAD wayside detectors use optimized area of the microphones located on each side of the track. The figure 9 microphones are spaced vertically and horizontally in the microphone. Spontaneous record of signal sensors identifying each of the wheel of the passenger train. The acoustic signal analyzed over the wide range of the frequencies since the rolling bearing flaws for the creating noise to produce an acoustic signature. The data analyzed association, presence of absence of the signature. The train passes the TAD detector sites at 30 to 50 miles an hour. The TEAS detectors are used to mitigate and failures and determine high-risk bearings. Identify the several defects of the Growler system. Growler software. Association American Railroads have developed a Rule 36A3C causing the removal of the Association American Railway Field Manual for Industry. The detection pertains to reducing burning off derailments. It can be used to customize alarm for the high-risk bearings and correlating with the hot bearings or set outs with acoustic alarms. inner ring cone defect, roller defect, outer bearing cup defect, damaged cups and cones, bearings. Typical TAD system review revenue service consisting with a microphone array and wheel sensors and AEI. Low air hose detector, LAD, low air hose detector, rail brake system depending on the operational integrity of the coupling of the hose, contacting air pipes by design with the coupling high hose, say, fails, becomes the otherwise uncoupled, but moving in the train puts it in an emergency brake condition, unintentionally decoupling and does occur with due to low-lying hoses. Figure 10, hiding objects in the roadbed at the minimum, resulting in emergency stop, causing delays, and may also damage wheels by creating flat spots, damaging landing. Current solution of the problem incorporated with non-contact optical sensing and approach, using infrared lights, concurrent sensors, and visual inspection for each of the air hose. The low air hose detector measures the distance between the top of the rail and bottom of each hose. Figure 11. Figure 10 shows the air hose station state in the train. Figure 11 shows a typical low air hose. The examination is performed only by the appropriate area between the vehicles to minimize the possibility of false alarm, to identify the leading and the trailing tags nearest to each of the lies below the defined threshold of the low air hose detector. Integrates with the AEI tag reducer, provided with a complete record of offending vehicles so corrective action may be taken in the most convenient location. Alright, THD, truck hunting detector. Hunting trucks underneath the rails cars can be violently oscillated. Figure 12, the only rail with the other transverse along the tangent track introduces electrical lateral force, significantly contribute to the rapid wear of the rail and the rail cars a relatively short time. In the worst, some hunting may be led to lead vertical wheel unloading, the wheel climb, derailment. As particularly type of the grade wheel vehicle performances, leading the cause of damage, delicate landing. A minimum of hunting trucks can be increased, but the fuel consumption, unchecked, serve damage for the truck components, and the derailment can result. Alright, this shows the lateral displacement of the axle and hunting truck. Measuring lateral instability indicates the truck suspension detects at the truck hunting detector. Wayside detector figure 13 can be used to identify the inspection maintenance procedure for the bad acting car, be reducing the derailments due to the flange climb. The hunting data collected by the TTCI was used to conform with both the hunting conditions and the condemnable defects. The representative cars of various levels of hunting performance sent to the TTCI inspection test teardown and repair. The teardowns show that suspect cars had worn components from the couplers and coupler. Carrier plates, doors, mechanisms. Also, the car shows signs of either both one and lower truck warp, resistant high worn wedges, column wear lines, and two low truck car body rotational constraints. No constant contact side bearings. No constant contact side bearing. Preloaded, melted, damaged. Constant contact side bearings. This data consists of approximately 300 cars a year. The hunting index equal to 0.65%, 0.65 hundredths, approximately 450 cars a year of the hunting index, or equal to half the cars of the 12-month period combined with the car with either above noted hunting induces the condemnable at any time as such the car hunting condemnable indices the two of the HI readings above the half or in 12 month 0.50 0.5 tenths monthly period with the HI reading of a 0.65, where they implemented the new Association of American Railroad interchange rule of July 1st, 2006, were adopted by the Association of American Railroad Field Manual Rule 46. Alright, your hunting track detector measurement, your lateral axle, rear rail and crib, your vertical hunting index, train speed, vehicle ID, and valid card library. Similar design to the wayside wheel impact detector of the truck hunting detector. Wayside detectors can be residing in the wheel impact load detector location. This adds only capability provides measurement of both array of the lateral force of the truck hunting detector exerted by the hunting truck and passing the train with the simultaneously reading with the vertical forces of the wheel impact load. As such, the dynamic relations between the vertical and lateral forces are fully accounted for. The identified with the critical instances where the engine, the rail, and the cage face may promote flange clip derailment. The measurement of the transform for the hunting of the index identified the excessive side-to-side motion of the bad acting cars. Some empty light loaded expectable truck hunting were operated with speeds over approximately 50 miles per hour in order to reduce severability of the truck hunting. Trucks are equipped with the features and constant contact, all side bearing, center plate, extensions, hydraulic snubber, and frame bracing the restaurant in the worn truck components that mitigates for the truck hunting. Hot box detector. The function of a hot box detector is to detect overheated journals. Overheated roller bearings, when indicated with lubrication mechanical flaws, result in increased bearing friction. The phenomenon is called the hot box in a railway jargon. The bearing temperature can be continued to rise, lead, and completely failure of the axle, commonly referred to as a burn-off journal. Burn-off journal normally results to as in derailment of the car when it occurs. So should example that happen when the train is proceeding, and the high-speed derailment frequently results in multiple cars derailed or damaged. In hot box conditions on a roller bearing equipped with rail cars can evaluate and quickly become a burn-off journal within a few limits. That shows the rolling bearings in a typical wear where the rolling bearings is scanned. Hot box detector senses radiant infrared heat energy emitted with the bearing and passed over the detector. In figures 14 and 15, the heat energy is converted with electrical output proportionally with the amount of heat relative to the ambient temperature. The ambient temperature is determined on a scan at the bottom of the rails as the pass of the data then processed through a warm and hot level. The amount of the energy sensed by the hot box detector exceeds the present value. The appropriate action is warranted. The hot box detectors are rated to work the ambient temperatures. Some of the environmental conditions, such as snowstorms, blowing snow conditions, heavy rain, and ice, can affect the quality of scanned data. The type of the housing used in the roller bearings, which the truck assembly, can impact the ability of the scanners to sense infrared heat energy. This shows your hot box scanner on the side, a typical hot box scanner on the field side of the track. Dragging equipment detector. This is new. The dragging equipment detector detects any object that hanging underneath the car or locomotive. The drag equipment detector may be two different designs, paddle mechanical style or impactor electronical style. Figure 17. The paddle consists of a strike plate and both. This is a dragging equipment detector paddle. Figure 16 and 17 impact detector. Dragging equipment detector location and accelerator meter underside of the strike plate. Inboard, outboard railway attached with the shaft and cam operated switch is a return spring. An objective striking the paddles either direction would rotate the shaft momentarily, opening a switch contacts and open circuit with a wood trigger alarm. The impact style is designed to alleviate the problems associated with the paddle style under the deep snow conditions. Has no moving parts. Stationary strike plate between the outboard rails are fitted with the accelerator meters and which detect the impact energy and sufficient impact energies and electrical output generators and alarm. Alright, your hot wheel detector, HWD. The function of a hot wheel detector is detected overheated wheels. Abnormally high temperatures indicate the brake pads struck with wheel treads. The condition causes a significant increase in friction, resulting in the hot wheels indicated brake palms. The hot wheel detector is similar to the hot bearing detector. It senses radiation with a heat energy using infrared scanner technology. However, the target instant with a wheel plate in the near of the tread, approximately 2.5 inches above the rail. Figure 18. Some of the systems of the hot wheel detector scanners on both sides of the track. Most of the only one scanner on one side of the track. When only one hot wheel detector scanner is used, the figure 19 scan wheels on both the near and far rail, and normally the set of the angle track of the outboard wheel surface of the wheel, the rail near the wheel can be scanned, and as can be inboard wheel plate surface the wheel on for the far rail. Reference temperature established by the placing of the whiteboard on the far side of the track opposite with a Hot Wheel detector scanner. The reference of the board is used to base the value and produce semi-absolute wheel plate temperature readings. The readings are compared to the present alarm threshold. If a wheel is cold during the brake application running down the grade, then its brakes are not working correctly. This shows an infrared sensor and a wheel plate over the scan and path of the temperature profile. A typical arrangement infrared sensor of the sensor wheel plate temperature. Figure 19 is super site revenue track showing the hot wheel detector, hot bearing detector, the dragging equipment detector, and the hot wheel detector has only one scanner on the angle of the track, while the wheel white reference board on the far side. It shows the side of the board for the aligning of the hot wheel scanner, the dragging equipment detector, a hot box scanner, and a hot wheel scanner. Load imbalance overload overload detectors. The detectors are used to reduce the derailment condition of the infrastructure damage, measuring the vertical loads on all wheels and the cars at track speed. Consequently, the measurement is detecting alarm and overload rail cars and balance rail cars. Figure 20. Since one of the vertical wheel loads of the essence of these detectors, Figure 21, lends themselves well adds on of the wheel impact load detectors. However, the standalone wayside installation of the detectors may sometimes be required. Using statistical analysis of multiple vehicle load measurements required of the detector is estimated with the statistical wheel of the rail is derived and to determine if the rail car is overloaded, imbalanced beyond safe operation limits. The detector may provide with the weight, motion, and the capability of the track speed so that the individual rail cars out of the surface of the wing is reduced. The corresponding weighing of the motion measurement, however, they may be effective with defective wheels, sometimes hunting trucks, or other degrading conditions that reveal themselves as process, such as the weighing accuracy of the detectors compared to low-speed revenue scale weigh bridges as detailable. These are used as alternative weighing motion systems and prerogative of the railroad, their customers, and the Association of American Railroads. Alright, this shows, figure 20 shows a case of imbalance of loading of a car. Figure 21 shows a LOID, which is load imbalance overload detector. Load imbalance overload detector consists of an angle iron bolt at the rail at every tie of the location. Also, the anchor railway ties the elastic clips. The angle iron instrumented with the crib location to measure the wheel loads, as shown with the load impact overload display. Overload detection can be detached and anchor as needed. We are aware of the worn wheels on the axle will always be non-symmetrical. Maintenance of the truck requires non-symmetry in the wear of the profiles. Wheels and pairs of the axles of the truck with reduce the minimum. The T-buggy, monitoring the T-buggy performance of the single track provides means of accessing as asymmetrical wheel pair of wheels for the axle determine the racking position, or TP. Interaxle misalignment and a track error at truck, the rotation truck shift. Figure 22, the T-buggy is the laser-based inspection system manufactured by the Wide Incorporated that scans the trains passing from the truck speed determined by the optical meanings of the geometry faults in alignment truck and the bogey system wheels set on the straight tangent track. The T-buggy operates on a tangent track alternate, eliminating the need for the special track layout. The non-contact laser sensors installed with the safe defense in Figure 23. The passing train, in order to interfere with the main track maintenance work, the measurement method embodied with the T-buggy provides the dynamic range of the yields. This doesn't result wide dynamic range of the T-buggy is identified with very suitable subtle buggy and performance deficiencies, which also capture the gross defects. The consistency of the data provided by the T-buggy allows the use of the train health of the rolling stock, thereby enabling the schedule of the maintenance of interventions, correcting impact and pending defects before consumption is raised over the damage. Figure 22 shows the definitions of possible displacement, rotation of the moving truck, track position, angle of attack, interaxle misalignment, tracking error, and technical error, tracking error, rotation, shifting. Figure 23 shows the T-Bogey deployments in freight, revenue, and high-speed Amtrak services. Double-track tow-bogey, the Amtrak's near Princeton, New Jersey. Characteristics: high-speed 230 mile kilometers. Highs of 140, electrified track, mixed traffic, high-speed passenger train, integrated with the Texas wheel and condition monitoring. Alright, features of the T-Bogey includes identified skewed and warped trucks, and identified with misaligned trucks, identified trucks that are incorrect wheel set tracking, identified trucks that wear the wheels symmetrically, diagonal wheel wear evenly before the severe wear sets. Identify the truck displaying lateral instability, truck hunting, non-contact series, sensors installed with a safe distance from the passing train to do interfere with the track performance work, installed on the tangent or track, no need for the special track layout, measurements insertive and sensitive to the change of the weather and rail lubrication conditions, measure the train speed of 200 miles an hour. Laser-based sensor provided with a high accuracy wheel set on the angle of the attack tracking position information. Acting on the data produced by the T-Bogey can enhance the safety, reduce the wheel set replacement, prolong truck component life, and reduce rail wear, reduce fuel consumption, and optimize maintenance resources. Preliminary guidance interpreting wayside detector and derailment causing finding prevention-related car equipment only. The distress to car and equipment arising operations involving the imbalance load, overloading, misaligned, and increased grade of the warped trucks, high old wheels, out of round, flat spot impacts, curved tracks, stuck brakes, impacts of the bridge approach, diamond switches, rail joints, and can be monitored with the wayside detection technology according to these three strategies. Wayside condition detectors, cracked axle detectors, cracked wheel detectors, thermal scanning, acoustic bearing detector, low air hose detector, dragging equipment detector, wayside performance detection, truck hunting detector, truck performance detector, wheel impact load detector, overload imbalance load detector, warning bearing trending, and wheel temperature trending. 3. Wayside machine vision technology, wheel profile model, brake shoe model, automated safety appliance inspection system, and automated inspection safety system components. The FRA has no regulations protecting the data located with the wayside detector as presented as such with the FRA can do in this data, along with the railroads finding the cause of the distressed equipment and infrastructure data. The effort of the AA Association of American Railroad Fields provided with the guidelines detector calibration thresholds on the collected for the data. Some of these thresholds of e.g. the wheel impact load and the truck hunting detector also mentioned in the prior detector description example. The Association of American Railroad condemnable alert of the wheel impact load of 90 KIPS to less than 140 KIPS. A single wheel represents a regular figure manual rule 41 condemnable level at any time. The final alert of the level is a wheel impact load of 140 kps and greater for the single wheel, represents a wheel having the impact level for the rail is so greater than that it places undue stress on both the wheel and the rail. Hunting usually occurs with the empty cars and speed greater than 50 miles an hour. Hunting detectors limits are given with the interchange of Rule 46. The responsible party is notified with the emergency HEMS system of the car, trucking, and the single of the truck hunting detector reading. Singlet systems, force-based truck hunting index greater than equal to 210. So considering as the window opportunities when the car is in home shop. However, the condemnable at any time using the track hunting detector details defined in either one a single high absolute value reading of 0.65 or 2 HI absolute value reading of 0.5 tenths in 12-month period. Or Rule 46 requires the home shop disposition requires for the car owner when the truck exceeds the condemning limits detected with the track hiding detector, wayside detector. Consequently, corrective steps required that A, the trucks be qualified and repaired for the Association of American Railroad specifications M214. Condemnable friction wedges replaced, and if the equipment constant contact side bearings were silent, the spring elements replaced. The roller blocks type of the system side bearings be placed on the Association of American Railroads M948. Approval of long travel steel kit. Constant contact side bearings. D. The side bearing adjustment component with replacement to be made with Rule 62. This next section we're able to reveal Manual 46 addressing the tip track inspection, repairing, especially side bearing adjustment with the repairing Rule 62. The Association of American Railroad Field Manual Appendix F and addresses the wild wheel impact and truck hunting detector calibration and validation data that requires truck performance detector along the criteria that are given with the field manual. Rules related to acoustic rolling bearing defectors, ABDs, as well as the field manual rules of 36 Appendix G covers initial combinations of the acoustic roller bearing detector, wayside detector, side validation. Field manual relates to the ABD wayside detector level 1 alarm, representing a specific minimum amount of bearing damage, considering is responding to at least one of the following. 2 square inches more of spalled area on any one cup of the cone running surface, 1 square inch spalled on any one cup of the cone running surface of 1/2 square inch and more spalled area on one other cup of the cone running surface. Any orange peel surface resembling a look of the texture of an orange. Any roller spall bearing, spall or seam, any loose of the compartment indication, cone race back face where greater than 0/10,000 of an inch. The indicated with these 1,000 indicated the spun cone of the corresponding axle journal, oversized cone borne on the dynamic growth evidence and turn on the axle journal. The 2 square inches more of the heavy water etched in the area indented sources on a cup of the cone running surfaces. If the automatic acoustic rolling bearing detectors wayside detector shows a level 1 alarm on the bearing that can be sent to the repair and to perform all hand rolling inspection for the removal of the further inspection. As a rule of thumb, the reason for the hot bearings attributed to the various failure progression modes, descending order of magnitude of significance, are water etched loose, fatigue, spalling, bearing, destroyed wheel defect, mechanical adapter, lubrication, display seal, and application truck related. Manufacturer defect, and of these above nodes and spalling water are each detected easily by acoustic. The acoustic bearing detector, wayside detectors evaluating the technology such as additional developing some of the percentages of other failures modes may also detect acoustic ability. And that does it for the book. I'm just gonna briefly go through the appendixes, we'll just scan them for you. I don't read appendixes unless I have a good reason or request.